Hey everyone. In this video, we're going to actually work on how to reverse the order of integration. Given this double integral, first we do dy and then we do dx. So what you want to do, you want to switch. So you want to write an equivalent integral where the order of integration is switched. So you want to do dx first and then dy. Now, switching them over this region is not so simple. So we need to actually draw the region first and then figure out if it's a type 1 and type 2. Now, since you see it is given as dy dx, we know it's a type 1 region, but you want to convert to a type 2 region. So we're going to go ahead and sketch. So let's go ahead and sketch the region. So here's our xy plane. Now, for this given integral, these are the bound on y. So y is going from 2 to the function 4 minus 2x, and x, so these are the bound for x, is going from 0 to 1. All right, so let's draw that. So here's our line x equals 0, so that's the vertical line on the y-axis, that's x equals 0, and then x equals 1, so that's right here. Let's say that's x equals 1. And now we're going to go ahead and draw the bound on the y. We have y is equal to 2. Let's suppose y equals 2 is somewhere right here. So that's y equals 2. And then for the upper bound for y, we have 4 minus 2x. So that's really just y is equal to 4 minus 2x. So when x equals 0, y is at 4. Let's suppose this is 4. And then when x equals 1, y is at 2. So that's right here. So we close it up and identify the region R. So R is this region right here. It's bounded by all of these curves. So this is what we're looking at. This is our region R. Now we want to integrate over this region, but we're going to reverse the order of integration, meaning we want to integrate along the x first and then y. So here's how we're going to do this. We need to find new bound for x and y. So we'll figure out what will be the new bound for x and y. So now since initially we're given this order, so initially that's what you're given. You're doing dy first and then dx. So if you're switching the order, you want to go this way, horizontal. That means that will allow us to go from right to left, and also from up and down will be bound on the y. So our bound on the y will go from constant to a constant, so they'll go from 2 to 4, but our bound on x will go from function to a function. So this would be the left curve, which is x equals 0, but the right curve will be this line right here. So we need to find the equation of that line. Well, we know that y equals 4 minus 2x. You have to solve for x in terms of y. So we're going to go ahead and subtract 4. So you get y minus 4 on both sides. Y minus 4 is equal to negative 2x. Divide by negative 2, so y minus 4 over negative 2 is equal to x. Little simplification gives us 2 minus y over 2 as the function for x. All right, so that will be our upper bound for x. It'll go from 2 minus y over 2. And there you have it. So let's put them in. So x will go from 0 to that function, 2 minus y over 2, and y will range from 2 to 4. So that's the equivalent statement for this integral. Another example here, let's go ahead and reverse the order of integration. So we are going to sketch the region first, but note that we're given dx dy, you want to switch it to dy dx. So we want to write an equivalent integral, a double integral, but the order now we want dy dx. So let's see how the region looks like. So let's make a sketch. So here is our xy plane, and our bound on x will go from these functions to, so from here to here, those are the limit of integration for x, and these are the limit of integration for y. So we're given that x ranges from y to square root of y, and y is ranging from 0 to 1. All right, so we're going to switch that, but let's sketch. So first thing I want to do is sketch the range for y. So we're going from 0, so that's just the x-axis itself, and then 1, so 1 is right here. This is 1. So I'm just gonna pull it up a little bit more. Let's suppose this is y equals 1. Now x is ranging from, the lower bound is y equals x. That's the curve. So y equals x, we know how that looks like. So that's this right here. Okay, so now the next curve we're going to draw is this one right here. So I'm going to do a little manipulation. So that one is x equal square root of y. And if you solve for y, you'll have x squared is equal to y. So that curve will look something like this. So it's just y equals x squared. So we got the line, this is y equals x, and this is x equals square root of y, or y equals x squared. Either of them is equivalent. All right, now we know they intersect right here, and you can check that by plugging in this point, and this point happens to be 1. All right, so the order that we're given, the region R is this right here. So it's trapped between these curves. That's the region R we're looking at. And the order we're given was dx dy, so we were doing it this way. That was the order we're given. So we had the right minus left curve, that's this right here. And then we have the outer integrals depending on y. Okay, so now we're going to reverse that. So instead of going vertical, we're going to, instead of going horizontal, we're going to create a vertical type 1 integral. So that's what we want. So we're going to have a top and a bottom, and we'll have the limit of integration for x 0 to 1. So here's how we're going to rewrite this. So our new bound, so x is going to range from a number to a number. So from here to here, that's 0 to 1. And y is going to range from a function to a function. So the lower curve and a top curve. So the lower curve is the parabola. So this is x squared. And the top curve will be the line x. And they're already expressed in terms of x. So that means our double integral, the equivalent double integral, the inner bound will go from x squared to x, and the outer integral will go from 0 to 1. So that will be the equivalent iterated integral.